minutes. Whilst we're waiting, it would be nice to get to know you all. Whilst we wait a few minutes, does anybody want to introduce themselves and just tell us why you've joined this session and whether you've used SQL before?
Hello. Hello.
Hello,
Hi.
Peter. Hello, Peter.
Hello. Okay. Sorry, I was testing my audio.
Yes, it works. Good.
Works. Thank you.
Have you done code in SQL before?
I remember I've been here once. Last time was for one of Excel
Okay. Yeah.
skills. Yes.
Okay. Brilliant. Yeah. So have you ever done any coding in SQL? Have you ever?
Yeah, I'm actually self-learning. Uh,
Okay.
the loads of websites. I'm currently using several of them to practice.
Okay.
It's
Okay.
kind
Brilliant.
of I don't know. Many people told me it's not difficult.
Yes.
And then when I was trying to solving some of the problems, oh my
Mm-hmm.
God, headache. Yeah. I mean, I can
Yeah.
do some, but
Yes.
not all of them. It's kind of yeah, kind of practicing.
It means you learn a lot. If you're getting a headache, it means you must be learning so much,
Yeah, yeah,
like
yeah. Because
overloading
I
yourself with a lot
am,
of new information.
yeah.
Okay, brilliant. And then who would like to go next? Who would like to tell us about their experience in terms of whether they've used SQL before? I think you're on mute. I can see a video of P. Sanobat, but we can't hear you because you're on mute.
Okay, yeah, can you hear me now?
I can hear you perfectly.
Okay, yes, good evening. Yes, I have tried using SQL before, but for some reason, whenever I try to run something, there's more than 50% chance that it doesn't seem to work. It's like, for some strange reason, you can't use SQL like you can with any other programming language. Uh,
Mm.
Yeah, and also if not used correctly, you also soon find that some of the way you write it can end up becoming very unwieldy. Uh,
Mhm.
yeah, so I want to find out his ways around that.
Okay, Brent, you're in the right place. Because our speaker here she's been learning SQL and she's been using it. And the great thing is, because she's a student herself, so because she's a student, so she's got to put herself in your shoes. You know what I mean? So it's not like, oh, she's been using it for 20 years or anything like that. She's relatively new, so she'll have an idea of maybe the challenges that you may be facing, and she'll still remember what it's like
Oh, wait, perhaps
when she
one
first
other
started.
quick thing I'd like to mention as well. If you try using SQL Server, that's actually even harder to understand than the SQL language itself. But whether we're going to actually cover SQL Server or SQL Workbench in any significant detail, I'm not sure.
Well, I can't answer that question. It's based on if anybody would like to share their knowledge on SQL Server. So, I don't know, are you in the LinkedIn group?
Which group?
LinkedIn. So on
Oh,
LinkedIn,
no,
I
I'm
have
not.
a, okay, so do you use LinkedIn at all?
I do, yes.
So what I'll do at the end of the session, I'll send you the link to the LinkedIn group. And if you send out a message, like, can anybody give information about SQL Server? Can they teach it? And then we'll see who shows their hands. So that's one way is actually find a body that's got experience with that and they might be willing to share the knowledge with you.
Okay.
And then I can then ask them, are they willing to come on a meetup and give a talk about it? Okay, so I'm just looking at the time. So 5 minutes has passed. So what I'll do, I think, because we've got quite a lot to cover, we're going to start. So just to tell you a little bit about our speaker today. Her name is Bukola Olafenwa. She has spoken before in this event. She's taught us a bit about some SQL views, but today she'll be doing inner joins. And when you're working with SQL, you probably notice that sometimes the information you want is not in one data set. You might need information from, for example, maybe 2 different data sets, and you need to join it together. So learning about inner joins, basically getting information from 2 different data sets or more, is very, very important. It's like a must. So that's why our speaker today is going to speak about it. So it's going to start off with giving you the theory, and then later we're going to go into some actual coding, and then you're going to see her demonstrate it with different practices. So don't worry, at the beginning, it's going to, for some of you, it might be like, oh, this is easy, I've done this before. For others, it'll be like, oh, it's interesting, this is how you do it. And then with each example, it'll get a bit more complex. Okay, and there'll be moments in the session where you'd be free to ask questions. But if you have a question and you're worried you might forget, you can just write it in the chat. And then when we have that question time, we'll answer those questions. Does that sound good?
Yeah, of course. Very good to me.
Brilliant. Okay, so I am going to allow, yeah, so there you go, Bukola. So if you'd like to take it away, please.
Okay, hello everyone.
Hello.
It's great to be here. Yes, I'm so happy to be, to be in the session tonight. It's not just about me presenting, but it's about us doing things together today. So I am Bukola Olafenwa. I am an academic mentor at the Letter Trust in London, and today we'll be discussing writing SQL inner joins. I've been following the discussion before we started, and then it has been about the challenges that beginners face, in trying to code using SQL. Yeah, it is okay. It is normal for someone to, encounter one issue or the other from the start. But as one practices, and then learns more, then one gets better. So that's the process with everybody. No one becomes a pro in one day. It starts from somewhere. And today, I hope we're going to have a nice time together discussing SQL inner joins. So this is not my first presentation on this platform. Yeah, my very first was about introduction to views, creating views using MySQL. And it was about, what views about, and then the syntax for writing views, as well as how to create them in 3 different ways. Firstly, by creating, views based on base tables, creating views based on the views that we have created, and creating views to replace existing views. But today we're going to be doing something entirely different, which is the writing inner SQL inner joins. So in my presentation, you should expect me to define what a join is, and then just to briefly highlight the different types of join we have. But then the focus will be on the inner join, and I'm going to introduce a syntax for writing an inner join, after which I will do live demonstrations of how to write an inner join using various examples. And finally, we're going to have a summary of today's presentation. So I think it's just good that we just go straight to business. What makes a join? What is a join? What defines a join? That word join is self-explanatory. The word join is suggests something.
Sorry, Bukola, are you able to share your screen, please?
Oh, I haven't shared my screen. I'm really sorry. I thought, oh my goodness, I'm sorry.
No worries.
Yeah, I'm sorry about that. Okay, screen. Oh, sorry. That I had. Okay. Okay. Okay, can you see it now?
It's starting. Yes, we can see it now.
Yes.
Okay, I'm really sorry about that. I don't know. So let me start all over again. So today we are writing SQL inner joins. My name, you can see the spelling correctly. I'm Bukola Olafenwa, but you can simply call me Bukola for easy pronunciation. So I'm an academic mentor at the Letter Trust in London. And in my presentation, I'll be defining a join, types of join, And then we're going to focus on inner join. I'm going to introduce to you the syntax for writing an inner join. And I'm going to be, demonstrating live codes, writing inner joins using various examples. And normally, I'm going to sum up the presentation for today. So, what makes a join? That is a very straightforward question. What defines a join? A join, as I was trying to say earlier before she called my attention to sharing the screen, a join is a word that is self-explanatory. That means more than one entity is involved. It involves linking, connecting, bringing together more than one entity. Now, a SQL join is a data analytical operation that is performed to retrieve data from fields of two or more tables in a single query. Meaning we have a single select query, and in that query, we'll be able to, query the database to return a result set that will retrieve data from two or more tables at the same time. It is possible, and it's only possible by using a join. Now I have an example of tables here from the sample database we'll be using today. So these are 5 tables in the database. So now, basically, what we're trying to say is, let's take for instance, maybe I want to retrieve data from the categories and products tables. Those 2 tables. Now, what I'm going to do is, I will have to join the categories and the products tables to retrieve the data from both tables. And to do that, what we need is a join. So you understand better as I explain further. Now, for us to be able to write a join to return our desired result set, there is something that is very important that we must know. And that is the fact that there is the role of a related field. By a related field, I mean a common field. As 2 or more tables are involved, data combination is needed based on a common field that connects the tables. Now, let's take, for example, the categories and products tables. Now, categories table has 4 columns: the category ID, category name, dates created and then modified, and the products, I think like 10 columns of fields. But there's one thing that is striking, and that is the fact that in both tables, there is a column that has the same name, and that's category ID. We have a category ID in the categories table, and we have a category ID in the products table. This is a field, a column, because a field can also be called a column can be called a field. So we can use both names interchangeably. So this field is common to both tables. And as a result, if we are to write a join, we can join both tables based on this category ID field that is common to both tables. Another thing is aliasing. And I think, every factor is just as equally important. In aliasing, we try to, give maybe like tables, for example, if we can alias a table in joins, giving it a temporary name, like a shorter name, a name that will be easy for us to type and will be so long. For example, let me come back here. Instead of saying categories, we can simply alias it as C. Instead of saying products, we can just alias it as P. So the moment we alias categories as C and products as P, it means whenever we write the C, we mean categories. And when we write the P, we mean products. For aliases, they represent both tables, and they would work well and get a desired result set using our join. But there are situations in which you may not need to alias, and there are conditions under which you must alias. So as we proceed, you know more about this. And again, there are different types of the SQL join. Today we'll be discussing the inner join. And then we have the outer join, cross joins. We also have self joins. But for tonight, I will just be highlighting these are the most popular types of joins. Those that are most commonly used by people, by coders. Now, the inner join that we will be focusing on tonight is a type of join that when we use it, it returns records that have matching values in both tables. Now, look, we have two tables here. We have table 1 and table 2. Now, the first table 1 is on the left, and then table 2 on the right. You should take note of that position. So when we want to write our join, when we write our inner join, we will join both tables based on a common field that both tables have, and it would give us a result set that would reflect data which both tables share in common. You will understand better as we move forward. Now, for left, I said table 1 is left on the left and table 2 on the right. So the left join, what it does is that it takes all the records, returns all the records from the left table, as well as where there are matching records from the right table. The right reverses the left outer join output by returning all the records from the right table and the matched records from the left table. Now, for full outer join, in MySQL, it is not supported, but in other, SQL flavors like ProgreSQL, for example, I'm sure ProgreSQL, it is supported in ProgreSQL, but that is not, this discussion for another day. Today, our focus is inner joins. So let's look at the syntax for writing an inner join. It's so easy, it's so simple to understand. Now, basically, the way, many is being taught, the way joins are taught is that when you want to write a join, you start with the from keyword, the from statement. Now, the belief is that you should be able to discern which table or which tables you will join to return your result set. Now, in this case, two tables are involved. So we say from the first table, inner join, or alternatively, you can simply say join. You can leave out the inner is optional. If you want to add it, you can add it, but you can just leave it out. And if you write join, it will still give you the same result set. It's fine. So you're retrieving data from the first table, which is the one on the left, inner join, the one on the right, and both tables will be matched. They will be joined on a column that is common to both of them. Now, this is table 1.column equals table 2.column. This means we are linking both tables on the basis of column in table 1 equals the column in table 2. After which, we now select the column list, that is the field list, the list of columns, the list of fields from which we want to retrieve our data from the database, from the various tables. So, but here, for me, it's, having been through, the learning experience, I sometimes prefer you just start by selecting the column list, and then you now specify the tables from which you're going to, take the columns, the fields. Because for me, it's kind of, for a beginner, it's kind of organized, structured, and it'll be easier to understand. So that is how I'm going to be writing the codes today. So, meanwhile, we have the syntax. But, in coding, there is, in many cases, more than one way of doing things. So now, there is another way we can actually, link these tables. Instead of using on, a column in first table equals column in second table, we can simply use using. Using is another keyword, another command that you can use to join both tables. And this is even, very handy, very easy to use. You just look at, okay, I'm joining both tables using the column that is common to both tables. So instead of you coming here to say, oh, on the column in the first table equals column in the second table, the moment you write that the field that is common to both tables in parentheses, you have specified that, oh, I am using this column that is common to both tables to join them. And then you get your result set. So this is a sample relational database, and I hope it's already in the group chat because Margaret?
Yes.
Okay, very good. Thank you very much. So the sample relational database as well as the codes for today are all in the comment section.
Yeah, so that will be shared at the end of the session.
Okay, all right, that's fine. So these are sample relational database. Is actually, it's called from my project that I did for Code First Girls. Yeah, and data SQL and data course. So, and it's handy and it will be very useful for analysis in this presentation. So what next? No, we have no time to waste. Let's just go straight into writing inner joins. Yeah, firstly, we have the sample question here, and this says we should retrieve the name, brand, price, and supplier name for all products. And now this is a snapshot of the code written without being aliased. And believe me, it works. So let's go right. I'll go right to my MySQL workbench to start my live presentation of the codes so that, everything we'll be discussing would make sense. So first is I'll try to call the database to specify the database I'll be using, the Express Grocery. That's the name of the database. I would run it and then it works. So now our first question says we should retrieve the name, brand, price, and supplier name for all products. Fine. Okay. Now, first, I'm selecting the column list. Now, this question is very explicit. It already tells us what our column list should contain. The name of the product, the brand of the product, the price of the products, as well as the name of the suppliers of all the products. Now, I want to go straight to the schema because, one of the reasons why codes may not work is when, the field list, is inappropriately referenced. And that includes writing a wrong name, incorrectly naming them. What specific names have been used to name the fields we are about to include in our codes? We have to be sure. So let me go directly to the schema. Here, we need supplier information and products information. So we'll be going to the products table, and then we'll be going to the suppliers table. Fine. So now let's start with products. The name is referenced as product name. So if we want our codes to run, we should not go there and write name. It wouldn't work. It should be product name, and then brand, and then price. So let's go and write this once. Select product name, and then we have the brand, then the price, and then supplier name. Remember, we're taking this information from two tables, the products and the suppliers tables. Now, let's the products table, let's make that the first one, which will be on the left. Products, inner join. As I said, you can simply say join, but I'm starting with inner join, so I have an experience, of including the word inner join suppliers. Now we are going to link both tables on the basis of a column that is common to both. Now let's go to the products table. Let me try and raise this. The products table, we have a supplier ID. We have a supplier ID in the products table. Good. Now let's come to suppliers. Definitely, it also has a supplier ID. So on this basis of the common field that they have, which is the supplier ID, we can join both tables. So now what we're going to do is, so we are joining them on the basis that the supplier ID in the products table equals the supplier ID in the suppliers table. Now, let me run the code. Yeah, we get our result set. Here, you have the information of the name of the products, and then for each name, the brand, the price, and the name of the supplier. Now, we have been able to do this without aliasing the column lists. Product name, brand, price, supplier name, they worked. And we're wondering, why did they work? When they have worked without us aliasing it, so we don't have to, aliasing is not that important. It becomes important when it gets to a certain point. So, but before I do that, I want us to run this same code now. Right? Now we're going to be using the using command. Now, the same code we have written. So instead of us saying blah 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 on the supplier ID in the products table where it equals the supplier ID in the suppliers table, we can just say using, and then we have our parentheses, and in the parentheses we have that field, that column that is common to both tables. Underscore, very good. Now, look at the difference here is we use on keyword where the supplier ID in the products table equals the supplier ID in the suppliers table, a long story. But here, we just say, oh, we are joining both tables using this column that is common to both tables, which is supplier ID in parentheses. And let's run the code. We get the same result set. Now, it's obvious that the using keyword, the using command makes work easier. So we'll discuss more on that as we move forward, as we go on. But now, let's try to now write another code, to write another code that would not be aliased, but then something happens that, that causes us to start thinking about aliasing the column list. Now let's come down here. Okay, it's still the same. Let me copy the question. Let's see. Okay. Now, what we had here was name, brand, price, and supplier name. Now I want to add supplier ID. and supplier name. So it's still the same code, but now I'm adding supplier ID. Now, let's try to run the code. After all, what we did the first time was having a column list. And what we have here too is just a column list. But now just one field has been added, and that's the supplier ID. So now let's run the code. Alas, it doesn't work. It doesn't work. As you can see the error code 1052, column supplier ID in field list is ambiguous. Why? I would appreciate if anyone from the audience can try to guess why this did not work. Why it has returned an error and it is telling us that that column name is ambiguous. Can anyone help us?
From my experience, there should be a comma after supplier ID.
Yeah, there should have been one. And one more.
Can you try this first?
And one more.
We got a message from Matab.
You said?
He said, we got a message in the chat which says, if the name of the column were not the same, as we can't use using.
Yes, we can. I'm still coming to that. Yeah, I know. I already reserved that for towards the end of the presentation. So for now, let's battle, all this and know. Okay, so what has happened is that we have included in the column list a column that is common to both tables. But we did not specify the supplier ID. Is it from the products table or from the suppliers table? One way the database management process works is that SQL in particular, when you want to query, you have to be specific. You have to, be specific in a way that the code would understand what you want and return the result set. So what we have failed to do here is we just took for granted the fact that we did not alias the first time and it worked, and now included a column that is common to the products and the suppliers tables without specifying which of the tables we have referenced it from. In this case, what we need to do is to alias the supplier ID is taken. We could have taken it from the products table or from the suppliers table, any of the two. But I would choose to take it from the suppliers table. Now, I have included here, I have specified now that I'm taking the supplier ID from the suppliers table. So let's see if it's going to work. Oh man, I have to drag this down. Oh my goodness, I'm coming. Good. You see, it works.
Okay.
It has worked because we have specified the table from which we have taken the field. Because now it's ambiguous. When a word is ambiguous, then it's you can give multiple meanings. So the field is kind of ambiguous because you can find it in the products table and you can also find it in the suppliers table. All we need to do is to specify which particular table do we want to extract the supplier ID from. And I've indicated that, okay, I want it from the suppliers table, and then the code understands the assignment and runs the code. Now, to avoid issues like this, you may have written your code so excellently, but you get to this point that you don't realize that you have included in your column list fields that are common to the tables you are joining, and then it begins to return error. You don't get your desired result set. So to avoid this, it is good that one should just make it a habit to always alias every column in the column list. Now, we've taken the product name from the products table. We can simply say we have taken product name to suggest that the product name is taken from the products table. Also, products brand to say that the brand is also taken from the products table. Likewise, price was taken from the products table. Products, that's price. And then supplier name is taken from the suppliers table. Suppliers, that's supplier name. And then we'll be safe in case maybe the product name occurs, concurrently in the suppliers and the products table. We wouldn't mind because we know we have, aliased, we have specified using aliasing the particular table from which we want the code to retrieve the data from that particular field that is common to both tables. Now, let me rerun this code now. And then we have our result set. So that's the safest way of writing joins. But then it is a tedious way. It's a tedious way because you can see it's too wordy. We have to do a lot of typing, writing products, suppliers, products. That's too much. To make work easy, what we need to do is, let me put this here, we alias the tables themselves. As I said, when I started, I used the categories and products tables as an example. I said I could just alias the categories table as C. I could alias the products table as P. And when I write the C, when I write the P, I'm referring to both tables. Now, what we're going to do here is we're going to alias using the ASCII. We're going to alias products as P. We're going to alias suppliers as SU. I prefer SU because I already have S for sales. And then here, where we specified that, where the supplier ID is taken from the products table equals the supplier ID from the suppliers table, we don't need products there. Since we have alias products as P, what we need to write here is P. What we need here is the SU. Here, for products, we don't need the whole of that. We just need the P because we have alias products as P. We don't need all this. It's just too much. One could spend the whole day writing products and suppliers. Yeah, you see, our code is lighter now. It's even more presentable, and it's well structured. So now it's time to start to try it on again to see if our code will work. Yeah, it returns our result set. Now, before I move to the next page, which is now, illustrating by writing the codes exactly I've done it in this last step. If there are any questions, I would like to, hear them. Maybe we could just iron them out in a matter of like a few minutes. And then we move on.
Just one simple, just to confirm.
Okay.
When I wrote it, I just ignore AS, so I don't write AS as a command. Is that fine?
It's fine. It would work. Yeah. Let me remove it. Let me just do that. Yeah. But the has for a beginner, it's kind of explicit.
Yeah, of course. It's easy to read.
Yeah. I will still get the same result set. It works.
Cool. Thank you.
Yeah, welcome. So the essence of the has is, it's kind of explicit, kind of guiding one to know the essence of the P. That, okay, products as P and suppliers as SU. So that's it.
Thank you.
Yeah, you're welcome. If there's no other question, then we'll move on. We have a few more questions. Now this time, we're going to be retrieving all products supplied by suppliers from Deptford. This is an interesting question. Now, we need to trying to drag this. I don't know, I'm gonna do it. Trying to drag it out of my way. Hide, hide, hide. Man. And try to drag it. Okay, maybe I should just leave it. Okay, now let's move on. Now, we are going to retrieve all products supplied by suppliers from a particular borough, which is Deptford. Now, as the question itself suggests, we're going to make use of the products table and the suppliers table again. Now, in our column list, to specify the products, I would like to include the product ID. Remember, I alias the product ID, the product table as P. So I'll just go on and start using it. P, the product ID. And then, okay, I can choose to suppliers from Deptford. Okay, let me SU. Let me use supplier ID. Just need the ID of the suppliers, just to be sure, of our result set. Yeah, so just these two. First, from the products table, as P. Inner join, I think we should just say join. The inner is an optional keyword. Join suppliers as SU on. Now, we know that that common field that both tables share is a supplier ID. So on supplier ID in the products table where it equals the supplier ID in the suppliers table. Good. And then it doesn't stop there. We have to filter our results. So we need the information of suppliers from Deptford. That takes us to the borough of the, let me open the suppliers. Good. Now that's the borough. We have Deptford. So where, that's when we use the where statement, where the borough in the suppliers table, remember, aliasing to avoid any clash, where the borough equals Deptford. And then let's try to run our code. Yeah, we have our result set. Good. So we have 3 suppliers from Deptford with the ID 3, 10, and 11. And these are the products that they supply. I choose to start with product ID before the supplier ID, making 2 columns. I may choose to make, the supplier ID maybe the first, like, okay. Okay, this comes down. This comes here. It's just the way, the ordering, any way you want it. Okay. Okay. Good. Now, this time around, I want to start with the supplier ID to know, the supplier before the product ID. So let me run the code. And then here, I think it's more readable here. It's more user-friendly. These are the suppliers and these are the products that they supply. Supplier ID 3 supplies products 5, 6, 7, 10, 20, 21, 23, blah, 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 and so on and so forth. So with our join, we have been able to retrieve information from the products and the suppliers tables. Now, our next question is retrieving the total sales amount for each product ID and name. Yeah. So this question, because some questions would not be really explicit, but I've made it explicit so that we'll be able to work with it easily. So now, in our select statements, we will definitely take data from the products table and the sales table. Now, in the sales table, here we have the sales underscore amount. That's exactly the way the sales amount column has been referenced. So when we want to write it, we have to use sales underscore amount. And as we can see, we have a product ID field as a foreign key in the sales table, meaning that the products and the sales tables, they have a common field, and that common field is the product ID, because we have the product ID in the products table and we have the product ID in the sales table. So what we're going to do is now, first is the product ID. We'll alias the products table as P, product ID. P, the product name. And now we're going to use an aggregate function. We're talking about, we want to retrieve the total sales amount. So we're going to use a sum function. So the sum of sales that is taken from the sales table, sales underscore amount. And this we're going to alias it for easy reference. So we're going to alias the sum of the sales amount as total sales. From products table as P, join, small letters, join the sales table as S on where the product ID field in the product table equals the product ID field in the sales table. So that's P, that's product ID. Product ID in the product table equals the product ID in the sales table. Now, we're not done yet because we use an aggregate function, the sum function. So we have to summarize our results using group by keyword. So the group by command, so we're going to group by product ID. That's just fine. And that's the product ID from, yeah, I think I would prefer to take it from the sales table. So product ID, and then I would like to order a result set. That's to order by, you can order by product ID or total sales. If you order by total sales, then we're going to get a result set with the total sales in ascending order. But if we want the product ID, we just have the product ID, like in ascending or descending order, whichever we specify. I think I should use let's use the product ID. The ID. And use either. So let's try to run our code. And yes, we have it. Good. So the product ID in ascending order. So this really helps us, it's like well organized. Product ID 1, blah, blah, the name and the total sales. Everything, just the information, the ID name and total sales for products. Yeah, that's have been sold. But if we want our total sales in ascending order, we can just order by total sales. Order by total sales. Remember, the total sales is the sum of the sales amount. It has been aliased as total sales. This would automatically in this ascending order. You see, So we have, yeah, rather than having a product ID in ascending order, we have the total sales from the lowest, increasing. So whichever appeals to us. So on this note, we move to the next question. And that is the total sales amount a salesperson, including salesperson name. Good. Now, let's go to the salesperson's table. Yeah, in the salesperson's table, we have, the names are specified as first name and last name. And we have a salesperson ID field in the salesperson's table, just as we have it in the sales table. As you can see, we have it in the sales table, salesperson ID. So that means both tables can be joined on that basis. So let's move on. Select first salesperson's name. So we're going to select, I'm going to alias the salesperson's table as SA. So we're going to get the first name from the salesperson's table. And then the last name from the salesperson's table. And then the sum of the sales in the salesperson's in the sales table, sales amount, aliased as total sales from the salesperson's table, salespersons as SA, join sales as S on that common field, which is the salesperson ID. That is where the salesperson ID in the salesperson's table equals the salesperson ID in the sales table. And because we have used an aggregate function, we have to group by, we summarize the results by the first name and then the last name and order by total sales. Let's order by total sales. And then let's run our code. Good. So we have 4 salespersons in total. And then for each salesperson, the first and last name, and the total sales they have made during the period of time that have been input into the database. This leads us to the next question that says that, okay, we want the salesperson. Okay. With the highest total sales amount. Yeah. Now, we have the result set for all the 4 salespersons and their sales. Now, but we want to return the result set for only the salesperson with the highest total sales amount. So what we're going to do is this code that has returned the result set for all of them, we need it. But this time around, instead of, ordering, sorting our results in ascending order, we do it in descending order so that we can start from the highest, and go to the lowest. And we're not going to stop there. We need just one. We need just one result. What's one row? And that is for the salesperson with the highest total sales amount. So we are going to limit our result set to just one. And then let's run our code. Yeah, and we have it. Abdul Jalal for £31, 8p. So I guess this is explicit. If there are no questions, we can just try to experiment with just one question involving 3 tables. We've been experimenting with 2 tables. This time around, like chains of joins, like of 3 tables. Let me just move on.
We have one person's made a comment. Do you want to say it out loud?
Okay.
The person that's made a comment in
Yes.
the chat.
Okay. I see it. What
So in the
else?
chat, Matab has said we can use max function also.
Yes, we can use max function also. Yeah, we can use max function also. It's possible. It's possible to use max. Yeah, it's possible. The maximum sales amount. Yeah. Yeah. It's possible. Yeah. It's possible. Yeah, I don't argue that. So there's more than one way of coding. I always say more than one way of coding. You can do it this way, in a way that is so flexible. Now, look, for example, the reason why I've used this is that because we already have the code. So instead of me I can just have said, okay, maximum, blah, 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 blah. No, just do it and just order in ascending order and limit to one result. And then we also have a result set. So it's fine. So let's move to...
We have one more question. Sorry.
Okay.
Somebody says, does order by statement only involve calculated columns and not primary columns?
Where I don't seem to get that.
Does order by statement only involve calculated? So I think order by, you can use it in different types of columns. Is that correct? So it's not only for calculated columns, you could use order by.
Yes, you can use order by for maybe columns or maybe aggregated columns. It works for any. For example, if the person was following me, I used one here. I think I used one here. When I was here, I used product ID to order this at some point. I said it depends on whatever you want, how you want your result set to be returned. Now, look at, I'm using a column, just a column to order by, and then you see, we have a result set. And I can choose to use the aggregated column, total sales, and then it works.
We just have one more question and then we'll move on for the time. Someone's just asking about which one is better for performance. I think this is in regards to...
One better for performance, it depends on what you want, as I said. Now, I've done this. Okay, now, look at, I wanted total sales in ascending order. That is why I've ordered by total sales. Now, look at this result set. Let me enlarge it. Now we have the total sales in ascending order. From the smallest, you can just follow. But you have to notice here that product ID starts from 30, 20, 20, 28, 35, 44. It's not ordered, it's not structured. And this is because we have chosen to order by total sales. But if we order by product ID, sometimes it is possible to order by more than one column, really. But I am just, that's the way it's kind of easy to deal with because, this is a kind of a beginner's level. So now if I order by product ID instead, this is what you get. Yeah. In the previous result set, we had total sales from the smallest You get it? And then it begins to increase and increase and increase. But now we have the product ID orderly structured from the first to the second to the third, fifth, sixth, seventh, 10, just like that in ascending order. And then if I now want this result in descending order, I can just say, okay, to start from maybe the highest total sales or the highest product ID, I can just write, use the DESE key. This comes in. Let me just bring this down. Yeah, modded up. Okay. Let me go back there. Very good. Yeah. You see? You see? Because we have ordered in descending order, then it starts from the highest product ID, 45, 44, 42, in descending order to 1. Or if we do not order in descending order, it starts from 1, which is the ascending order. I hope my explanation is explicit enough.
Yeah,
and
I
I've been
think
able to answer the question.
what they meant was, are you aware there's any difference in speed? You know, like if you were to use max instead of limit, like would it be faster using max compared to limit, or as far as you're aware, it takes the same amount of speed to run?
Okay. All right. Yeah, it could be, I think it's the same.
Might be
It's the same
same.
process
Okay.
for me.
Yeah.
It's the same
Okay.
process for me. I don't want to waste much time on that. It's the same
Yeah.
process for me. Yeah. But I don't want to waste time on that. Yeah.
So are
It
we
works,
happy?
works
Is
fine.
everybody happy to do one more example? Should we do one more example?
Yeah, this time with 3 tables.
Yeah.
Okay. Let's move on. Okay, let me just do this one
Great, thank
more.
you.
Yeah. Retrieve category name and then product name as well as supplier name for all products. Okay, here we have 3 tables. Now, the categories, products table and the suppliers tables. We're going to be retrieving data from the 3 tables. So I'm going to alias the categories table as C. So I'll just go straight to point to say C, the category name. P, the product name. And supplier, SU, the supplier name from. First, I will start with the products table because it's the link between the categories and the suppliers table. The products table has a foreign category ID key and it has a foreign supplier ID key. So on that basis, we can join both the 3 tables. So I'm going to be starting from products as P, join the categories table as C on on where the category ID in the products table equals the category ID field in the categories table. So we now have P, that's category ID, equals C, that's category ID. Now, we're going to add another join. This join that we have written already. There's a second join. Now we're going to join one more table, which is the suppliers table. Suppliers as SU on the basis of the products and the suppliers table having the common supplier ID field. So where the supplier ID in the product table equals the supplier ID in the suppliers table. Dot supplier ID. So let's run our code and okay. Down. Yeah, what's wrong? What have I done wrong? See. Suppliers as you. Supplier ID. See. Not seeing anything wrong here. Okay, wow. I missed the S, the suppliers. Very good. Good. So we have a result set. So for here, we have the name, category name, product name, and the supplier names for all the products. So on this basis, we have been able to link the three tables. So what was initially raised, because of time, I can't go into many things, but something that was initially raised with concerning using the using key. Yes, it is true. When the fields that are common to both tables do not have the same name, the using command would not work. That is the reason why when you have a database, for example, the database we're using now, the using can work because all the tables, both their primary keys and the foreign key counterparts, they have the same name. But for fields that have common values but different names and the different tables I want to join them, the on keyword, the on command, the on statement is the best. So I want to experiment it. Let me just try. Let me take this. Okay. Let me take this. Fully aliased one. Take this. Come down here. Yeah, using command. Okay, now instead of the on, I'll just let me put this here. So when we're done, we're just gonna experiment with it. Now I'm going to use using instead of on, and in parentheses I'll have the supplier ID. Okay, good. So now let's try to run it. It works. It works because both fields, they are common to both tables and they have the same name. But let's try to change the name of that column, that field, in one of the tables to a different name. It's the same field, common to both tables, with the same values, but in a different name. So let's try to alter the suppliers table. Alter table, suppliers, and then rename column supplier ID to ID. Let's try to do that. Let's check the action output. Yeah, it works. So now let's try to select all. Yeah, from suppliers. Let's see. Yeah, we now have it as ID. Before it was supplier ID, now have it as ID. So now let's try using this, using command, yeah, it would definitely return an error because the name has changed. The name is no longer common. The values still remain valid. The values are common, but the names have become different. As a result, it wouldn't work. So now let's try supply ID for product table. So let's try ID itself. It's still going to give us the same error. It will cause the same error. Unknown column ID from the class. But when we use the on, it works. Because the on is more explicit in saying, oh, we're taking the supplier ID from the products table and then the ID from the suppliers table. So now let's run this. Where ID, change it to ready. Supplier name. Okay, yeah, there's this, oh God, this, yeah, ID, not supplier ID. Okay, good. Very good. So we have our result set. Because here, the on keyword, as you know, is more explicit in specifying, oh, I'm taking where the supplier ID in the products table equals the ID field in the suppliers table. So on this basis, it works. So that is why the on statement is, you know, kind of superior to the using statement. But then both are useful depending on the database you want to use. If you're not familiar with your database, I think it's just safe to use the on. But if you're familiar with it and you know that, yes, every primary and foreign key in the different tables, they have the same name. Yeah, I think to make work easier, you just use the using command and everything would work well. I don't know at this point if there are questions regarding the presentation generally, what we have covered in this session today, apart from the questions that have been asked before that I've already answered.
Yeah, so we have one question here.
Okay.
We can't use using, comma, supplier underscore ID, comma ID.
Let me see.
It might be easier, yes, if you read the
It's-
message.
I don't think it's a question. It's kind
Okay.
I think it's a statement.
No.
of it's a
The
statement.
way now you see, there's something we call the composite primary key. So it is possible that could be a composite foreign key. If there is any, then in this we have the sales, for example, I have a composite primary key. The sales ID and the sales date both together are primary keys. They make a composite primary key. That is 2 in 1. In that case, if we want to use this, that means we are going to join tables that also have, these are primary keys here. We're going to join tables that have foreign keys with the same fields in the same name because it is using. If it is on, then they can have different names. But here, I don't know, I'm trying to break it down. I don't know how to say it better. We have 2. Yeah, it is possible to say, yeah, I want to join on, where the sales ID in the first table equals the sales ID in the second table, and it's possible. And the sales date in blah blah table is equal to the sales date in another table. Yeah, it works. It can work. But this database cannot. I don't think it will be able to work for it because there's just one foreign key, establishing relations between tables. One primary key and then the foreign key counterparts in tables that are related. So it's a relational database, but it is not the type that is flexible enough to try such experiments. So I hope I've been able to answer the question.
Thank you. Thank you.
Yeah.
Well, is that all? So thank you very much. I've just looked at the time, it's 1:15. So thank you very much, Bukola, for showing us, talking about inner join in SQL. And thank you as well for preparing this presentation and for answering the questions. Bukola will share, she will share her coding if you would like to take a look at it. And maybe even, will you be sharing the database as well? Or is it just the coding?
Yeah, you can share the database. You can share the database and the coding.
Okay.
Yeah.
So,
Yeah.
so what I would do, what I'm actually going to do, I'm going to, what I would do, I will send out a message, if not today, then tomorrow on
Okay.
Meetup that will have a link to the
Okay.
code and the presentation and the database.
Oh,
So
okay.
then
All right.
so
That's
the-
fine. That's
actually give
fine.
it a try and,
Yeah.
and try them out.
Yeah. Yeah. That's good.
But
Yeah. Thank you
thank you
everyone
very much.
Yeah.
That
Wow.
was very good.
Thank you very much, Bukola.
Yes, yes, yes.
Thank you very much. Nice. It's a very nice refresher.
Thank you. I like that. I like to know. Yeah. It's good to know. Yeah.
Thank you very much.
And if anybody has any other subjects that they would like to learn in SQL, please do use Meetup and just kind of state, what you'd like to learn. And Bukola has nicely said that she will be teaching other things in SQL in the future. So
Yes,
Well,
I actually is like I'm going to run this like a series. We started with inner join. Maybe my next presentation will be on left join. Yeah. And then the next right join, full outer join, and then cross join, self joins in that order. Yeah.
yeah,
oh, nice.
brilliant.
I'll look forward to it.
Okay. All right. Thank you.
Time from it. Thank you very much.
Yeah. You're welcome.
Brilliant. Thank you all. Bye.
Thank you. Bye. Bye.
Bye.
Bye.
Okay, I'm looking forward to your LinkedIn group
Yes, definitely.
as well. Yeah, I'm in already.
Yes.
I think I'm in.
You are in. Brilliant.
Yeah. Okay then.
Brilliant.
Thank you very much. Have a nice evening.